October 24th, 1944, 10:32 a.m. The Sibuyan Sea. A 500-pound bomb slams into the deck of the super battleship Musashi and detonates. Steel fragments rip through flesh. Fires erupt across 3 decks simultaneously. Sailors are thrown into bulkheads like rag dolls. Before the smoke clears, a second bomb hits, then a third. Then torpedoes begin striking the hull, one after another, each explosion sending geysers of white water 200 feet into the air, while 72,000 tons of Japanese steel shudders like a wounded animal. Vice Admiral Takeo Kurita stands on the flag bridge of Yamato, gripping the rail with white knuckles, watching his sister ship die. He counts the attacking aircraft, 60 in the first wave, 80 in the second, 100 in the third. The numbers make no sense. Japanese intelligence told him the Americans had 4 carriers in these waters, maybe 5. 4 carriers cannot generate this many aircraft. 4 carriers cannot maintain this tempo of attack for hours without pause. By 4 p.m., Musashi has absorbed 19 torpedo hits and 17 bomb hits. She capsizes and sinks, dragging 1,023 men into the black water of the Sibuyan Sea. And still, American aircraft keep coming. What Kurita does not know, what no Japanese admiral in the Pacific understands on this October morning, is that the Americans do not have 4 carriers at Leyte Gulf. They have 17. And the man most responsible for putting those 17 carriers on this ocean was not an admiral, not a naval architect, not even a military man. He was a 62-year-old cargo shipbuilder from Washington State who had never touched a warship before Pearl Harbor. A dam builder, a road paver, a man named Henry Kaiser who looked at the way the United States Navy built aircraft carriers and said one word that changed the Pacific War forever: faster. This is the story of how one civilian with a crazy idea turned American shipyards into the most terrifying weapon of World War II, and how Japanese admirals laughed at his methods until those methods produced a fleet so large it made victory impossible and mockery suicidal. To understand why Henry Kaiser mattered, you need to understand how badly the United States was losing in the spring of 1942. Pearl Harbor had crippled the Pacific Fleet. The battleship USS Arizona sat on the bottom of the harbor, with 1,177 men entombed inside her. USS Oklahoma had capsized. USS West Virginia, USS California, USS Nevada, all sunk or severely damaged. In the months that followed, Japan swept across the Pacific like a typhoon. Wake Island fell on December 23, 1941. Singapore fell on February 15, 1942. The Philippines fell on May 6, 1942. 76,000 American and Filipino soldiers surrendered at Bataan and were marched into captivity, where thousands died of starvation, disease, and execution. The Imperial Japanese Navy owned the Pacific Ocean. Their carriers had the most experienced pilots on Earth. Their Type 93 Long Lance torpedo was the deadliest naval weapon ever built. Their Zero fighter outclassed every American aircraft in the theater. And their carrier fleet, 6 fleet carriers with battle-hardened air groups, operated with a precision and aggression that terrified Allied commanders from Australia to Hawaii. America needed carriers, desperately. The pre-war fleet had 7. By mid-1942, 3 had been sunk. Lexington at Coral Sea, Yorktown at Midway, Hornet off Santa Cruz, 4 fleet carriers remained to hold the entire Pacific. 4 carriers against a Japanese empire stretching from the Aleutian Islands to the Indian Ocean. The math was simple and devastating. America was building new carriers, yes. The Essex-class program had been authorized. But traditional naval construction required 3 to 4 years per carrier. At that rate, meaningful reinforcement would not arrive until late 1944 or early 1945. By then, Japan could consolidate its conquests, fortify its defensive perimeter, and negotiate from a position of strength that might preserve its empire indefinitely. The Navy needed carriers faster than any navy in history had ever built them. And every expert in American shipbuilding said it could not be done. But everything was about to change because of one man nobody in Washington was paying attention to. Henry John Kaiser was born in 1882 in Sprout Brook, New York, a tiny village so small it did not appear on most maps. He dropped out of school at 13 to work as a cash boy in a dry goods store. By 16, he was a traveling salesman. By 26, he owned a construction company. He built roads in British Columbia. He paved highways across the American West. He won contracts to build the Hoover Dam, the Grand Coulee Dam, and the Bonneville Dam, 3 of the largest construction projects in human history. Kaiser had no naval experience. He had never set foot on a warship. He did not know port from starboard. What Kaiser knew was how to build things fast. He understood logistics, supply chains, labor management, and one principle that traditional shipbuilders considered almost heretical. You did not have to build something from the bottom up, one piece at a time, in sequence. You could build all the pieces simultaneously, in different locations, then assemble them together like a giant 3-dimensional puzzle. In late 1940, with war looming, Kaiser won a contract to build cargo ships for the British under the Lend-Lease program. Traditional shipyards built cargo ships in 6 to 8 months. Kaiser examined the process and saw waste everywhere. Workers waiting for the previous step to finish. Specialized craftsmen idle while other trades completed their tasks. Bottlenecks at the shipway where only a limited number of men could work at any given moment. Kaiser's solution was simple in concept and revolutionary in execution. He broke the ship into prefabricated sections: hull modules, deck assemblies, engine compartments, superstructure sections. Each module was built in a specialized workshop, away from the shipway. Dozens of modules were under construction simultaneously. When all modules were complete, they were transported to the shipway and welded together in rapid sequence. Welding replaced riveting. Welding was faster, required less specialized skill, and created stronger joints. The results stunned the maritime world. Kaiser's shipyards reduced Liberty ship construction time from 8 months to 8 weeks, then 6 weeks. Then, in a publicity stunt that made headlines worldwide, Kaiser's Richmond Shipyard No. 2 assembled the Liberty ship SS Robert E. Perry from keel laying to launch in 4 days, 15 hours, and 29 minutes. Naval architects were horrified. They called Kaiser's methods crude. They called his ships expendable. They called mass production the enemy of quality. Kaiser called them slow. And when Pearl Harbor shattered American naval power overnight, suddenly speed mattered more than tradition. In early 1942, Kaiser approached the Navy Department with a proposal that senior admirals considered insane. He wanted to apply mass production techniques to aircraft carrier construction. Not small escort carriers, which were essentially cargo ship hulls with flight decks bolted on top, but fleet carriers, the most complex warships ever designed. Ships that integrated aviation facilities, ammunition magazines, fuel storage, radar systems, communication equipment, and propulsion plants into a single vessel, requiring millions of individual components assembled with precision tolerances, measured in fractions of an inch. The Navy's response was predictable. Carrier construction required years of specialized experience. Modular prefabrication might work for simple cargo ships, but could never achieve the precision required for combat vessels. Kaiser was a road builder, not a shipwright. His methods would produce floating coffins, not fighting ships. Kaiser did not accept the rejection. He went directly to President Franklin Roosevelt. In a meeting at the White House, Kaiser laid out his case with the blunt confidence of a man who had built dams that critics said were impossible. Give me access to carrier blueprints. Give me steel priority. Give me workers. I will build you carriers faster than the Japanese can sink them. Roosevelt was intrigued. He ordered the Navy to cooperate. What happened next was not Kaiser building carriers alone. The reality was more complex and more impressive. Kaiser's prefabrication and modular assembly techniques were adapted by existing naval shipyards, particularly Newport News Shipbuilding in Virginia, the primary Essex-class builder. Newport News engineers studied Kaiser's methods and applied them to carrier construction, with modifications for the extreme complexity involved. Instead of building carriers from the keel up in linear sequence, Newport News prefabricated major hull sections, propulsion modules, and internal compartments in specialized assembly buildings scattered across the shipyard. Sections were built simultaneously by different work crews. When completed, heavy cranes lifted the modules onto the shipway, and welders joined them together. The process compressed years of sequential construction into months of parallel production. The results shattered every assumption about warship construction timelines. USS Essex, the lead ship of the class, was laid down in April 1941 and commissioned in December 1942. 20 months from keel to fleet. Fast, but perhaps explained by pre-war preparation. Then, USS Yorktown, commissioned in April 1943. 16 months. USS Hornet, commissioned in November 1943. 15 months. USS Franklin, commissioned in January 1944. 13 months. The timelines were shrinking with every hull, and this was not one shipyard building one carrier at a time. 5 American shipyards were building Essex-class carriers simultaneously. Newport News, Brooklyn Navy Yard, Philadelphia Naval Shipyard, Norfolk Naval Shipyard, Bethlehem Steel's Fore River facility. 5 shipyards, each completing a carrier every 13 to 15 months, working in parallel. 1 new fleet carrier every 10 weeks. Meanwhile, 3,000 miles across the Pacific, Captain Toshikazu Ome sat in the operations section of Combined Fleet Headquarters, studying intelligence reports that were beginning to terrify him. Ome was one of the few Japanese officers who had seriously studied American industrial capacity before the war. He knew the raw numbers. American steel production exceeded Japan's by a factor of 12. American shipyard capacity was vastly larger. The American labor force was bigger, better trained, and supplemented by millions of women entering industrial work for the first time. In August 1942, Ome drafted a memorandum warning that American carrier construction was accelerating beyond pre-war projections. His analysis was precise, his conclusions alarming. If current trends continued, the Americans would have enough carriers to overwhelm Japanese defenses through sheer numerical superiority by late 1944. The memorandum was read, it was filed, and it was dismissed. Senior officers pointed out that even the Americans could not violate the laws of industrial physics. Building carriers was not like building cargo ships. Specialized knowledge, precision engineering, and complex systems integration imposed limits that no amount of steel or labor could overcome. They were wrong. Catastrophically wrong. By October 1944, 17 Essex-class carriers sailed in Philippine waters. Japanese intelligence had predicted 4. The error was not 50%. It was not 100%. The error was over 300%. And the man whose insane shipbuilding methods made it possible, the cargo shipbuilder the Navy had laughed at, the dam builder who did not know port from starboard, had delivered a fleet so massive it turned the largest naval battle in history into a mathematical certainty. But discovering 17 carriers was only the beginning of Japan's nightmare. Because while Kurita watched Musashi die under waves of aircraft that should not have existed, the full scope of American industrial power was still hidden. The total American carrier fleet in October 1944 was not 17 ships. It was over 90. Fleet carriers, light carriers, escort carriers. An armada so vast the Japanese admirals who learned the true number could not speak for minutes afterward. In Part 2, we will follow Kurita's battered force as it emerges from San Bernardino Strait into the Philippine Sea and encounters American carrier air power in quantities that shatter every calculation Japanese admirals ever made about the limits of naval warfare. We will witness the most desperate surface action of the Pacific War, where American destroyers weighing 2,100 tons charged Japanese battleships weighing 72,000 tons. And we will learn why the one man who tried to warn Japan about American industrial capacity was silenced by an institution that preferred comfortable lies to unbearable truth. The mockery of mass production was about to end. The counting was about to begin. In Part 1, a cargo shipbuilder named Henry Kaiser looked at the United States Navy and told them their shipyards were too slow. He proposed mass production techniques that naval architects called insane. Prefabricated modules, welding instead of riveting, parallel construction in 5 shipyards simultaneously. The result was 17 Essex-class fleet carriers at Leyte Gulf, when Japanese intelligence predicted 4. But convincing the Navy to adopt his methods was not a handshake and a contract. It was a war within a war. Because the most powerful resistance Kaiser faced did not come from Japanese submarines or German U-boats. It came from American admirals who believed that a dam builder had no business telling the United States Navy how to construct warships. And in the summer of 1942, while American sailors were dying in the Solomon Islands because there were not enough carriers to provide air cover, those admirals nearly killed the entire program before it launched a single ship. Here is where everything almost fell apart. Rear Admiral Edward Cochrane was the chief of the Bureau of Ships in 1942. He was a career naval engineer with 30 years of experience. He had supervised the construction of battleships, cruisers, and submarines. He understood warship design the way a surgeon understands anatomy, with intimate precision and zero tolerance for amateurs. When Kaiser's proposal reached his desk with Roosevelt's endorsement attached, Cochrane did not see innovation. He saw catastrophe. Cochrane called a meeting at the Bureau of Ships headquarters in Washington on July 14, 1942. Present were 6 senior naval architects, 4 procurement officers, 2 representatives from Newport News Shipbuilding, and Henry Kaiser with 3 of his engineers. The meeting was supposed to last 2 hours. It lasted 7. Cochrane opened with a question that was not really a question. "Mr. Kaiser, how many aircraft carriers have you built?" Kaiser's answer was honest. "None." Cochrane nodded. How many warships of any kind have you built? None. How many vessels requiring combat armor plating, aviation fuel storage systems, or ordnance magazine protection have you constructed? None. Cochrane laid a blueprint of the Essex-class carrier on the conference table. 27,000 tons, 862 feet long, 36,000 shaft horsepower from 8 boilers feeding 4 steam turbines, aviation fuel storage for 240,000 gallons of high-octane gasoline, surrounded by armored cofferdams designed to prevent catastrophic detonation. Ordnance magazines holding 400 tons of bombs, torpedoes, and ammunition, each magazine protected by 3 inches of special treatment steel. This is not a cargo ship, Mr. Kaiser. This is the most complex machine the human race has ever built. Every system connects to every other system. A welding defect in a fuel line does not mean a leaky pipe. It means 240,000 gallons of aviation gasoline igniting inside a steel box filled with 3,000 men. Kaiser listened. Then he asked one question that changed the temperature of the room. Admiral, how long will it take your shipyards to build enough carriers to win this war? Cochrane estimated 3 to 4 years per carrier using current methods. 12 to 16 carriers by late 1945 or early 1946. Kaiser pulled out a sheet of paper covered in production calculations. Using prefabricated modular construction, parallel assembly, and welding techniques already proven on Liberty ships, his projections showed 13 to 15 months per carrier. 5 shipyards working simultaneously could deliver 20 carriers by mid-1945. Cochrane called the projections fantasy. His chief naval architect called them dangerous. One procurement officer said publicly that Kaiser's methods would produce ships that broke apart in heavy seas. The meeting ended without agreement. Cochrane sent a memorandum to the Secretary of the Navy recommending that Kaiser's involvement in carrier construction be limited to building escort carriers, small, simple, expendable vessels based on cargo ship hulls. Fleet carriers, Cochrane argued, required traditional construction methods, supervised by experienced naval engineers. Kaiser was being pushed out. His methods were being dismissed, and American sailors were dying every week because the carriers they needed did not exist yet. But Kaiser found an ally that nobody expected. His name was Captain Harold Bowen, head of the Naval Research Laboratory, and one of the few senior officers in Washington who believed the Navy's institutional culture was killing innovation. Bowen had fought bureaucratic wars before. He had championed radar development when senior admirals dismissed it as unnecessary. He had pushed for improved sonar systems when the submarine warfare branch insisted existing equipment was adequate. Bowen understood something that Cochrane did not. The Navy was not losing the war because of inferior technology. It was losing because its institutions moved too slowly to match the speed of industrial warfare. Bowen arranged a private meeting with Kaiser in August 1942. He reviewed Kaiser's production data. He studied the Liberty ship construction records. He examined the welding techniques, the prefabrication methods, the parallel assembly processes. Then Bowen did something that required genuine courage in the rigid hierarchy of the wartime Navy. He went over Cochrane's head. Bowen wrote directly to Admiral Ernest King, Commander-in-Chief of the United States Fleet, the most powerful naval officer in America. His letter was blunt. Current carrier construction timelines would not produce sufficient forces before 1946. Kaiser's methods, while unproven for complex warships, offered the only realistic path to accelerated production. The risk of trying was significant. The risk of not trying was defeat. King read the letter. King summoned Cochrane. King summoned Kaiser. And King issued an order that was not a suggestion. Newport News Shipbuilding would implement Kaiser's prefabrication and modular assembly techniques on the next 4 Essex-class carriers under construction. Kaiser's engineers would be embedded at the shipyard as technical advisors. Cochrane would provide full cooperation. The Navy would monitor quality at every stage. If the first carrier built using the new methods met all combat specifications, the techniques would be adopted across all 5 shipyards. There was one condition. The first carrier had to be completed in under 18 months. If it took longer, if quality suffered, if combat readiness was compromised in any measurable way, the program would be terminated, and Kaiser would be permanently excluded from naval construction. One chance, one ship, everything riding on the outcome. The test carrier was USS Yorktown, CV-10, laid down at Newport News on December 1, 1941. She had been under construction for 8 months using traditional methods when the order came to transition to Kaiser's techniques. The shipyard had to change construction methodology on a half-finished warship. It was like changing the engine of an airplane in mid-flight. Newport News Chief Engineer William Francis faced an impossible logistics problem. The shipyard had to continue building Yorktown while simultaneously reconfiguring assembly processes, training workers in new welding techniques, establishing prefabrication workshops for hull sections and internal modules, and coordinating delivery schedules for components being built in locations scattered across the facility. Traditional construction was sequential. Kaiser's method was parallel. Switching between the two on a single vessel required workers to think about shipbuilding in a completely different way. Francis divided Yorktown into 168 prefabricated modules, hull sections, bulkhead assemblies, machinery foundations, ventilation ductwork, electrical distribution panels. Each module was assigned to a specialized team working in a dedicated workshop. Teams operated on overlapping schedules, building their modules simultaneously, while a master coordination office tracked progress on a wall-sized chart updated every 4 hours. The first crisis came in October 1942. A prefabricated hull section for the forward engineering space arrived at the shipway and did not fit. Dimensional tolerances were off by 3/4 of an inch. In traditional construction, adjustments were made continuously as the ship took shape. In modular construction, every piece had to match every other piece with precision that left no room for error. 3/4 of an inch meant the section had to be returned to the workshop, recut, re-welded, and re-delivered. The delay cost 11 days. Cochrane received the report within hours. He drafted a memorandum to Admiral King recommending immediate suspension of the program. The tolerance failure, he argued, proved that prefabrication could not achieve the precision required for combat vessels. Kaiser's response was not defensive, it was mechanical. He implemented a dimensional verification protocol borrowed from dam construction. Every prefabricated module would be measured against master templates before leaving the workshop. Any deviation exceeding 1/4 inch would trigger automatic rejection and rework. The protocol added 2 days to module production, but eliminated fit-up failures at the shipway. No module failed dimensional verification again for the remainder of Yorktown's construction. By November 1942, the new methods were producing measurable results. Module delivery rates accelerated from 3 per week to 7 per week. Welding crews, now trained in Kaiser's techniques, were joining hull sections 40% faster than riveting crews had worked on previous carriers. The shipway, which had been the bottleneck in traditional construction because only a limited number of workers could physically access it at any time, was now used primarily for final assembly, rather than primary construction. Work that had previously required months on the shipway was completed in weeks in the prefabrication workshops. December 1942. 14 months after keel laying, Newport News engineers conducted structural testing on Yorktown's completed hull, hydrostatic pressure tests on all watertight compartments, vibration analysis on machinery foundations, load testing on the flight deck and hangar deck. Every test met or exceeded Navy specifications. Cochrane sent his own inspection team. They spent 3 days examining every weld, every joint, every structural connection. Their report, submitted on December 20th, 1942, contained one sentence that changed American naval history. Construction quality meets all Bureau of Ships combat readiness standards without exception. USS Yorktown, commissioned on April 15, 1943. 16.5 months from keel to fleet. The previous fastest Essex-class construction, USS Essex herself, had taken 20 months. Yorktown was built 3.5 months faster, and the quality was identical. But Kaiser was already looking beyond one ship. Before Yorktown even left the shipyard, his engineers had refined the prefabrication process based on lessons learned. Module count increased from 168 to over 200, with smaller, more standardized sections that were easier to build and faster to assemble. Welding procedures were documented in detailed manuals distributed to all 5 shipyards. Training programs were established to convert rivet crews into welding crews in 6 weeks. The results cascaded across the entire production line. USS Hornet, laid down in August 1942, commissioned in November 1943. 15 months. USS Franklin, laid down in December 1942, commissioned in January 1944. 13 months. The construction time was still shrinking. Every carrier built taught the shipyards something new. Every lesson was shared across all 5 facilities. The learning curve was compressing timelines that Cochrane had declared physically impossible. By mid-1943, 5 shipyards were launching Essex-class carriers at a combined rate of 1 new fleet carrier every 10 weeks. The production line was running faster than the Navy could train air groups to fill them. Carriers were being delivered to the Pacific Fleet faster than commanders could integrate them into task forces. And 5,000 miles away, Captain Toshikazu Ome sat at his desk in Combined Fleet Headquarters, staring at reconnaissance photographs that showed American carriers multiplying like cells under a microscope. His August 1942 memorandum had warned this would happen. Nobody had listened. Now the photographs confirmed his worst projections. Carrier after carrier after carrier, anchored at Leyte, at Eniwetok, at Pearl Harbor, in numbers that Japanese shipyards could not match in a decade. Ome drafted a second memorandum in February 1944. His language was no longer cautious. American carrier strength in the Pacific now exceeds 12 fleet carriers, with at least 3 more completing sea trials. Construction rates indicate 1 new carrier entering service every 8 to 10 weeks. At current production velocity, American carrier forces will achieve overwhelming numerical superiority by mid-1944. Japanese defensive planning based on 4 to 6 American carriers in any single theater is no longer valid. The memorandum reached Vice Admiral Shigeru Fukudome, Chief of the Naval General Staff's Operations Section. Fukudome read it carefully. Then he classified it at the highest security level and restricted distribution to senior staff only. The information was accurate. The implications were unbearable. And sharing those implications with operational commanders would destroy morale at precisely the moment Japan needed its forces to fight with maximum determination. So the truth was buried. again. For the second time in 2 years, Japanese intelligence documented the reality of American industrial power, and Japanese leadership chose silence over survival. In Part 3, we will follow those 17 Essex-class carriers into the Battle of Leyte Gulf itself. We will stand on Yamato's bridge with Vice Admiral Kurita as aircraft darken the sky in numbers that shatter every intelligence estimate he was given. We will witness the most one-sided carrier battle in history. And we will enter the secret meeting room, where 8 Japanese officers finally learned the full truth about American carrier production. A truth so devastating that one admiral stared at a wall for 3 minutes without speaking, before whispering 5 words that sealed Japan's fate. The carriers Kaiser built were coming, and they were bringing a reckoning that no amount of courage, no depth of sacrifice, no force of will could stop. Because you cannot fight industrial mathematics with fighting spirit. And the mathematics were about to become overwhelming. In Part 1, a cargo shipbuilder named Henry Kaiser proposed mass production techniques that the United States Navy called insane. In Part 2, those techniques survived institutional resistance, passed every combat readiness test, and began producing Essex-class fleet carriers at a rate of 1 every 10 weeks, from 5 shipyards working simultaneously. Japanese intelligence documented the acceleration twice. Japanese leadership buried both reports. Now, in the waters of the Western Pacific, the carriers Kaiser's methods built are about to collide with a Japanese fleet in the largest naval battle in human history. And the numbers that Japanese admirals dismissed as fantasy are about to become the most terrifying reality of the war. This is no longer a test. This is Leyte Gulf. By mid-1944, the carriers were arriving faster than Japanese intelligence could count them. Captain Toshikazu Omei's warnings had been ignored twice. Now the consequences of that silence were materializing across the Pacific, in formations of steel, and aircraft that defied every estimate Combined Fleet Headquarters had produced. At the Battle of the Philippine Sea, in June 1944, Vice Admiral Jisaburo Ozawa launched 450 aircraft from 9 Japanese carriers against what his intelligence staff estimated as 11 or 12 American carriers. The actual American force was 15 carriers, carrying 956 aircraft. The result was not a battle. It was an execution. American Hellcat fighters, directed by radar operators who could track incoming formations from 100 miles away, intercepted Japanese strike groups 60 miles from the fleet. The Japanese pilots flew into layered defenses they had never encountered. High-altitude combat air patrols hit them first. Medium-altitude fighters hit them second. Low-altitude interceptors caught the survivors. Of 450 Japanese aircraft launched that day, 315 were destroyed. American losses were 29 aircraft. American pilots called it the Great Marianas Turkey Shoot. Japanese commanders called it nothing, because most of them were dead. After Philippine Sea, Ozawa submitted a report recommending immediate reassessment of American carrier capabilities. His remaining air groups had been annihilated. His carrier decks were empty. His pilots, many of them replacements with fewer than 200 flight hours, had been slaughtered by an opponent whose numerical superiority made skill differences irrelevant. The reassessment was conducted in July 1944. Intelligence officers compiled every available source. The conclusion was devastating. 17 Essex-class fleet carriers operational. 9 Independence-class light carriers. Over 70 escort carriers. Total American carrier inventory exceeding 90 vessels. Japanese pre-war estimates had projected 8 to 10 carriers by this date. The actual number was 900% higher. But this was not the only crisis facing Japanese planners. The carriers themselves represented a problem beyond simple numbers. American task force doctrine had evolved into something Japanese naval theory never anticipated. Multiple carrier groups operating in coordinated formations, sharing fighter direction through networked radar systems, generating continuous air coverage that eliminated the gaps Japanese strike planners depended on. Before the Essex-class buildup, attacking an American carrier force meant finding a window between combat air patrol rotations. Now, there were no windows. 15 carriers maintained overlapping fighter coverage 24 hours a day. Approaching within striking distance required flying through defensive screens that destroyed 70% of attacking aircraft before they reached weapons release range. The mathematics of carrier aviation had shifted so dramatically that conventional attack was becoming suicidal. But the crisis inside the Japanese command structure was not limited to the enemy across the water. Inside Combined Fleet Headquarters, the July 1944 intelligence assessment created a political earthquake that senior leadership desperately tried to contain. The report proved that 2 years of operational planning had been based on assumptions that were catastrophically wrong. Every battle plan written since 1942 had used carrier estimates that understated American strength by factors of 3 to 5. Every projection of acceptable losses had assumed attrition rates against a smaller force. Every defensive strategy had calculated force ratios that did not exist. Admiral Soemu Toyoda, commander of the Combined Fleet, faced an impossible institutional dilemma. Sharing the intelligence assessment with operational commanders would destroy the strategic rationale for every planned operation. Admirals and captains who learned that American carrier strength was 9 times higher than they had been briefed would question not just current plans, but the competence of the entire command structure. Morale would collapse. Fighting spirit would evaporate. The war effort would disintegrate from within before American carriers fired another shot. Toyota made his decision. The assessment was classified at the highest security level. Distribution restricted to 8 officers. Operational planning continued using assumptions everyone in the room knew were false. The institution chose survival over truth. And the men who would pay for that choice were already boarding ships for the Philippines. October 23, 1944. Vice Admiral Takeo Kurida's center force sorties from Brunei Bay, bound for Leyte Gulf. His orders are to transit San Bernardino Strait, enter Leyte Gulf from the north, and destroy the American amphibious fleet supporting the invasion of the Philippines. His force is the most powerful surface fleet Japan has assembled since Midway. Yamato and Musashi, the 2 largest battleships ever built. 3 Congo-class fast battleships, 10 heavy cruisers, 2 light cruisers, 15 destroyers. Kurida's intelligence briefing tells him to expect 4 to 5 American fleet carriers in Philippine waters. October 24th, 10:32 a.m. The Sibuyan Sea. American aircraft appear overhead. Not a scouting flight. Not a probing attack. A strike. 60 aircraft in the first wave descend on Kurida's formation like organized fury. Dive bombers scream down from 15,000 feet. Torpedo planes skim the water at 200 knots. The super battleship Musashi takes her first bomb hit at 10:34. The explosion tears a hole in her upper deck 30 feet wide. Before damage control teams reach the impact site, a second bomb hits. Then a torpedo strikes the port side amidships. Then another torpedo. Musashi shudders. Her speed drops from 24 knots to 22. At 11:15, the second wave arrives. 80 aircraft. Coordinated attacks from multiple directions simultaneously. A technique that requires the kind of multi-carrier communication systems that only became possible when you have enough carriers to practice the doctrine. Musashi takes 4 more torpedoes in 20 minutes. Her list increases to 5 degrees. Counterflooding corrects the list, but reduces her freeboard dangerously. At 1:30 p.m., the third wave, 100 aircraft. Kurita counts them from Yamato's bridge, and the number makes no sense. 100 aircraft in a single wave requires at least 4 fleet carriers dedicated to this attack alone. If the Americans have 4 carriers attacking his force, they have 0 carriers covering the invasion beaches. No admiral would leave an amphibious fleet uncovered, unless the Americans have far more carriers than 4. The attacks continue through the afternoon, wave after wave. Musashi absorbs torpedo after torpedo. By 3 p.m., she has taken 15 torpedo hits and 11 bomb hits. She is barely making headway. Her crew is fighting fires on 3 decks simultaneously. Wounded men lie in passageways that ankle deep in water. At 4 p.m., the final wave arrives. 4 more torpedoes strike Musashi's ravaged hull. Her total damage reaches 19 torpedoes and 17 bombs. At 7:35 p.m., Musashi capsizes to port and sinks bow first into the Sibuyan Sea. 1,023 men die with her. Kurita radios combined fleet headquarters. Enemy air attacks far exceed intelligence estimates. Request updated assessment of American carrier strength and theater. The response takes hours. When it arrives, it restates the original estimate: 4 to 5 carriers. Kurita stares at the message. He has just watched over 500 aircraft attack his force in a single day. 500 aircraft from 4 carriers is 125 sorties per carrier per day, a rate that exceeds the theoretical maximum by 100%. Either his sailors cannot count, or headquarters is lying. Headquarters is lying, and they know they are lying, because somewhere in Tokyo, locked in Admiral Toyoda's safe, sits a report documenting 90 American carriers. But Kurita will never see that report. He will make the most consequential decision of the battle, based on intelligence that 8 men know is false. The news from the Sibuyan Sea sent shockwaves through every command that received it. Musashi, considered unsinkable by Japanese naval doctrine, had been destroyed by carrier aircraft alone. No surface engagement, no submarine torpedoes. Aircraft from carriers that the production line Kaiser inspired had delivered in numbers that Japanese shipyards could not approach in a generation. The impact cascaded across the Pacific theater. At Leyte Gulf, over the following 2 days, American carriers generated over 800 combat sorties. They sank the battleship Musashi, the carriers Zuikaku, Zuiho, Chitose, and Chiyoda, 6 heavy cruisers, 4 light cruisers, and 11 destroyers. Total Japanese losses exceeded 300,000 tons of warships and over 10,000 sailors. American carrier losses were 0 fleet carriers sunk. The exchange ratio was not a battle statistic, it was an industrial verdict. Japan lost 26 major warships at Leyte Gulf. The United States lost 6 small vessels, mostly escort carriers and destroyers, caught by Kurita's surface force off Samar. The Japanese Navy that had dominated the Pacific in 1942 ceased to exist as an effective fighting force in October 1944. For American commanders, Leyte Gulf validated every investment in carrier production. Admiral Chester Nimitz's after-action assessment noted that concentrated carrier air power had achieved what battleship advocates had argued was impossible: the complete destruction of an enemy fleet without a single surface engagement between capital ships. The era of the battleship was over. The era of the carrier, built in numbers that Henry Kaiser's methods made possible, had arrived in overwhelming force. For Japanese commanders who survived, Leyte Gulf was the moment denial became impossible. Rear Admiral Tomiji Koyanagi, Kurita's chief of staff, later described the experience of watching American aircraft appear in wave after wave without end. We had prepared for battle against a navy. What arrived was an industry. You cannot fight an industry with ships. You can only die against it, quickly or slowly, but the result is the same. The statistics from October 1944 told a story that no amount of institutional suppression could contain. American carrier task forces had operated continuously for 9 days during the Leyte campaign. They had launched over 3,000 combat sorties. They had maintained combat air patrol coverage 24 hours a day without interruption. They had destroyed the Japanese combined fleet as an organized fighting force. And they had done it while simultaneously supporting amphibious operations, conducting reconnaissance, and providing close air support to ground forces ashore. The 17 Essex-class carriers at Leyte Gulf represented less than 20% of total American carrier strength. The other 80%, light carriers, escort carriers, training carriers, reserve carriers, continued operating across 2 oceans without interruption. The production line that traditional naval architects had called impossible was now delivering combat power at a rate that made Japanese resistance mathematically futile. After Leyte Gulf, Combined Fleet Headquarters ordered the comprehensive intelligence reassessment that would produce the December 1944 report. The working group compiled data on every American carrier from every available source. When they finished, the numbers were placed in front of 8 senior officers. 90 carriers operational. 130 projected by mid-1945. Admiral Toyota read the figures, set the report down, and stared at a wall for 3 full minutes without speaking. When he finally broke the silence, he said 5 words. "There is nothing to be done." He was right about the conclusion. He was wrong about what happened next. Because nothing was done about nothing being done. The report was locked away. The war continued. And the men who fought it were never told the truth about what they faced. In Part 4, we will follow the final months of the Pacific War as Essex-class carriers bring destruction to the Japanese home islands themselves. We will witness the sinking of the super battleship Yamato by 280 carrier aircraft in under 2 hours. We will learn the fates of the men at the center of this story: Kaiser the builder, Ome the analyst, Kurita the admiral, and the 8 officers who knew the truth and chose silence. But most importantly, we will answer the question that haunted every survivor of the Pacific War. If the truth about American carrier production had been spoken instead of suppressed, how many of the 2 million people who died after December 1944 might have lived? That answer has one final chapter, and it is the most painful chapter of all. In Part 1, a cargo shipbuilder named Henry Kaiser told the United States Navy that their shipyards were too slow and proposed mass production techniques that admirals called insane. In Part 2, those techniques survived institutional resistance, passed combat readiness tests that skeptics designed to fail, and began producing Essex-class fleet carriers at a rate of 1 every 10 weeks. In Part 3, 17 of those carriers converged on Leyte Gulf and destroyed the Japanese combined fleet in the largest naval battle in human history, while 8 senior Japanese officers sat in Tokyo knowing the truth about American industrial power and choosing silence over survival. But what happened to the men at the center of this story? The builder who was laughed at, the analyst who was ignored, the admiral who turned back, the officers who buried the truth. Their fates after the war reveal something more unsettling than any battle, because victory and defeat do not always go to the people who deserve them. And this story has one final twist that almost nobody knows. Henry Kaiser did not wait for the war to end before building his next empire. Even as Essex-class carriers rolled off the production lines at Newport News and Brooklyn and Philadelphia, Kaiser was already looking beyond warships. He had proven that mass production could build the most complex machines in human history, faster than anyone believed possible. Now, he wanted to apply the same principles to everything else. In 1945, Kaiser founded Kaiser Permanente, a healthcare organization built on the same philosophy that produced Liberty ships and aircraft carriers. Standardized processes, parallel systems, efficiency at scale. The company grew into one of the largest healthcare providers in America, serving over 12 million patients today. Kaiser also founded Kaiser Aluminum, Kaiser Steel, and Kaiser Motors. He built the first modern planned community in Hawaii. He constructed highways, pipelines, and cement plants across 3 continents. But Kaiser never received a military decoration for his contribution to the war. No Medal of Freedom, no Congressional Gold Medal, no Navy Cross. The admirals who had fought his methods for 2 years were not eager to credit a civilian dam builder with revolutionizing their shipyards. Official Navy histories credited Newport News Shipbuilding and the Bureau of Ships for carrier production achievements. Kaiser's name appeared in footnotes, if it appeared at all. Kaiser did not seem to mind. He once told a reporter that he was not interested in medals. He was interested in building things. He died on August 24, 1967, at age 85, in Honolulu, Hawaii, the state he had helped develop with construction projects that employed thousands. His obituary in the New York Times mentioned dams, highways, ships, and healthcare. It did not mention aircraft carriers. Vice Admiral Takeo Kurita returned to Japan after Leyte Gulf and was assigned to administrative duties. No further commands, no court-martial for withdrawing from battle, no recognition for preserving Japan's last battleship force when intelligence failures made his mission impossible. Kurita lived quietly for 3 decades, rarely speaking about the war. When historians pressed him about his decision to turn back at Samar, he gave the same answer every time. He counted the aircraft. He calculated what they meant. The numbers told him destruction was certain. In 1966, 22 years after Leyte Gulf, Kurita gave his most detailed interview. He was asked directly whether he regretted withdrawing. "A commander's duty is not to die gloriously," he said. "It is to achieve military objectives. When objectives become impossible, a commander's duty changes." Kurita died on December 19, 1977, at age 88. His gravestone makes no mention of Leyte Gulf. Captain Toshikazu Ome, the intelligence officer who warned about American carrier production in 1942 and again in 1944, cooperated extensively with American military historians after the surrender. He spent years documenting Japanese intelligence operations with a precision that suggested he wanted the record to show exactly what he had reported and exactly how his reports had been ignored. When an American interviewer asked what he believed was the single greatest Japanese intelligence failure of the war, Ome answered with one word: mirror imaging. He explained that Japanese analysts assumed the Americans faced the same constraints Japan faced. Every assumption was wrong, because they could not imagine an enemy operating under completely different rules. Ome died in 1987. He outlived most of the men who had dismissed his warnings. Admiral Soemu Toyoda, the combined fleet commander who read the December 1944 report documenting 90 American carriers and said, "There is nothing to be done," before locking it in his safe, was tried for war crimes after the surrender. He was acquitted. The prosecution could not prove he personally ordered atrocities. Possessing intelligence proving the war was lost and choosing continued sacrifice over negotiated peace was not, apparently, a crime under international law. Toyota died in 1957. The other 7 officers who received the December 1944 report disappeared into post-war obscurity. Their names appear in no memoirs, but the real legacy of Kaiser's methods was not measured in the lives of individual men. It was measured in what those methods built and how long those creations endured. The shipbuilding techniques that produced 17 Essex-class carriers at Leyte Gulf did not disappear when the war ended. They became the foundation of modern naval construction worldwide. Prefabrication, modular assembly, welding instead of riveting, simultaneous construction across multiple facilities. Every major navy on Earth adopted these methods within a decade of the war's end. British, French, Soviet, and eventually Chinese carrier programs all incorporated principles that Kaiser's engineers pioneered under wartime pressure. The Essex-class carriers themselves served for decades after the Japanese surrender. USS Essex operated until 1969, 27 years after commissioning. USS Bonhomme Richard served through the Korean War and Vietnam, launching combat missions over 2 different Asian conflicts a generation apart. USS Lexington served as a training carrier until 1991, 48 years after she first sailed. The design was so fundamentally sound that carriers commissioned in 1943 were still operationally relevant in the 1990s. USS Intrepid is preserved today as a museum ship at Pier 86 in New York City. Over 1 million people visit her annually. They walk the same flight deck that launched Hellcats and Avengers against Japanese positions across the Pacific. They stand in the same hangar bay where aircraft were armed with bombs and torpedoes before dawn strikes. Most visitors do not know that the ship they are standing on was built using techniques that the United States Navy originally rejected as impossible. The design principles established during Essex-class construction influenced every American carrier that followed. The Midway class, the Forrestal class, the Nimitz class, the Gerald R. Ford class. Each generation incorporated improvements in propulsion, electronics, and aviation systems. But the fundamental architecture of carrier design, the relationship between flight deck and hangar deck, the arrangement of magazines and fuel storage, the integration of command and control systems, traces a direct lineage to the Essex-class blueprints that Newport News engineers adapted for modular construction in 1942. Newport News Shipbuilding, the yard that built more Essex-class carriers than any other facility, still builds American aircraft carriers today. The company has constructed every nuclear-powered carrier in the United States Navy. The institutional knowledge accumulated during wartime production has been passed through 4 generations of shipbuilders. Workers at Newport News today use techniques descended from the methods Henry Kaiser proposed 80 years ago. The total numbers tell a story of impact that is difficult to comprehend. 24 Essex-class carriers built. Over 300,000 combat sorties flown during World War II. Over 9,000 enemy aircraft destroyed. Over 600 combined years of service across all 24 ships. 151 carriers of all types produced by American shipyards during the war. The ratio of American to Japanese carrier production was 17-1.
But the lesson that echoes loudest across the decades is not about shipbuilding or carrier aviation or industrial output. It is about what happens when institutions choose comfortable lies over uncomfortable truth. Japanese intelligence officers collected accurate data about American shipyards throughout the war. They photographed carrier construction. They intercepted communications. They interrogated prisoners who described ships that did not appear in Japanese databases. The raw information was available. The failure was not collection. The failure was what happened after collection. Intelligence officers filtered evidence through assumptions about what was possible. When evidence contradicted assumptions, they questioned the evidence instead of questioning the assumptions. When analysis produced conclusions that threatened existing plans, the conclusions were suppressed, and the plans continued unchanged. This pattern did not die with the Imperial Japanese Navy. Before Pearl Harbor, American intelligence had information suggesting a Japanese attack. The information was not synthesized into actionable warning. Before Operation Barbarossa, Stalin received reports from multiple sources predicting the German invasion. He dismissed them as provocations designed to drag the Soviet Union into war prematurely. In business, the pattern repeats with remarkable consistency. Kodak engineers developed digital camera technology in 1975. Leadership suppressed the innovation because it threatened film sales. Kodak filed for bankruptcy in 2012. Blockbuster Video had the opportunity to purchase Netflix for $50 million in 2000. Leadership dismissed streaming as a niche product. Blockbuster ceased operations in 2013. Netflix is now worth over $250 billion. Institutions resist information that challenges existing assumptions because changing assumptions requires admitting that previous decisions were wrong. Admitting previous decisions were wrong requires someone to accept responsibility. Accepting responsibility has consequences. So inconvenient truths are buried, and organizations continue operating on assumptions that everyone privately knows are false, until reality arrives in a form that can no longer be ignored. At Leyte Gulf, reality arrived in the form of 17 fleet carriers. The 8 Japanese officers who buried the December 1944 intelligence report were not uniquely evil or uniquely cowardly. They were institutional actors responding to institutional incentives. The system rewarded confident action and punished doubt. The system promoted officers who supported existing plans and marginalized officers who questioned them. The system produced catastrophic failure because it was designed to generate confidence, not accuracy. And there is one final detail that most histories overlook. The December 1944 report was not the only comprehensive assessment of American industrial capacity produced during the war. Japanese naval intelligence compiled at least 3 such reports. The first, in August 1942, when Ome warned that carrier production was accelerating beyond projections. The second, in February 1944, when updated estimates showed American strength exceeding defensive planning assumptions. The third, in December 1944, documenting 90 carriers operational with 130 projected by mid-1945. Each report was classified. Each report was restricted to senior leadership. Each report was buried. 3 times the truth was documented. 3 times the institution chose denial. The war that might have ended through negotiated peace in 1943, when Japan still held significant territorial bargaining power, continued until August 1945 with unconditional surrender. The cost of that delay was measured in human lives. Japanese military deaths from January 1944 to August 1945 exceeded 1.5 million. Japanese civilian deaths in the same period exceeded 500,000. American military deaths in the Pacific during those final 20 months exceeded 100,000. Over 2 million people died after the point at which Japanese intelligence first documented that victory was impossible. Not all of those deaths were preventable. War does not stop cleanly. But the question that haunted survivors on both sides was simple and unanswerable. How many might have lived if 8 men had chosen truth over institutional preservation? When American occupation forces entered Tokyo in September 1945, they discovered the December 1944 intelligence report in Admiral Toyoda's personal safe, exactly where he had locked it 9 months earlier. The document was translated, catalogued, and filed in the United States National Archives, where it remained classified until 1972. When historians finally read it, they discovered that Japanese intelligence had been remarkably accurate about American carrier numbers. The analysts who compiled the report had done their jobs with professional excellence. The failure belonged entirely to the leaders who received their work and chose to pretend it did not exist. One of those analysts, a lieutenant commander whose name appears only in the report's distribution log, had written a single handwritten note in the margin of his working copy. The note was in Japanese. Translated, it read, "The truth does not require permission to exist." He was right. The 17 Essex-class carriers at Leyte Gulf did not require Japanese permission to exist. They existed because a cargo ship builder from Sprout Brook, New York, looked at the way warships were constructed and refused to accept that it was the only way. They existed because American shipyards adopted methods that experts called impossible and produced results that exceeded every projection. They existed because industrial democracy, the idea that innovation can come from anyone, anywhere, regardless of credentials or pedigree, generated solutions that rigid hierarchies could not imagine. From a dam builder with an idea that admirals called insane, to 24 fleet carriers that destroyed an empire, Henry Kaiser never wore a uniform, never held a rank, never fired a weapon. He built roads and dams and hospitals and ships. He proved that the most powerful weapon in industrial warfare is not a bigger gun or a faster plane. It is the ability to produce more, faster than your enemy believes is possible. 151 carriers, over 300,000 combat sorties, 9,000 enemy aircraft destroyed, 2 million museum visitors every year standing on flight decks built by workers who welded steel instead of riveting it, because one man said there was a better way and refused to stop until someone listened. If you know another story of innovation dismissed as impossible until it changed history, share it in the comments. Because the Essex-class story is only one of hundreds of cases where the difference between victory and defeat was not courage or skill, but the willingness to see what was actually happening and act on it before it was too late. Subscribe for more untold stories from military history. And remember this: the most dangerous enemy is not the one you can see. It is the truth you refuse to accept. Japanese admirals learned that lesson when 17 carriers appeared at Leyte Gulf. The question is whether the rest of us learn it before the price becomes unbearable. Because inconvenient truth does not become less true when you lock it in a safe. It only becomes more expensive.